Okay, so second version of this um, video solutions to the review packet. All right, so Marie says if a triangle is an obtuse triangle, then it cannot, okay, be an isosceles triangle. Using a diagram, show that Marie is incorrect and indicate the measures of all the angles and sides. That's a dangerous. Let's not do that. I'll show. Um, we can't guarantee the sides, but we can guarantee the angles. So we'll take that off if that comes up on a test. Um, all right, so here it is. So we're going to make these two the same, and we're just going to make this more than 90 degrees to make it obtuse. Okay, so the biggest angle is going to be, let's just assume for 100 for a minute. Now, all you have to do is leave enough, 180 is what it takes to make a triangle. So we've only used up 100. We still have 80 left for two angles. We can divide that by 2 and get 40 apiece. Okay. Now, the reason we have to make those two the same is so that it is, in fact, isosceles. If two angles are the same, then two sides are the same. Now, it is true that you can't have two obtuse angles. Okay, so that is, in fact, true. We couldn't have two 100-degree angles because now we're over 180, and 180 is our limit. Okay, so it does say to justify your answer. Okay, angles of a triangle add to 180. The measures actually have a sum of 180. So an obtuse angle over 90 degrees leaves us with enough for the other two angles. Okay, so that's all we did. All right. Yeah, and then this also works to justify too. You know, that right there is part of the justification. All right, so they're parallel, A and B, so we can mark them with these arrows, and then they want the measure of angle 1, okay, in degrees. Good, right there. All right, so because of parallel, what we want to look for is, let's try to, let's see, we have this Z right here. Yeah, that's not going to help us, so get rid of that. What is going to help us? Okay, alternate, oh no. So that's our transversal. That's 74, and this angle right here are in the same position. So if we ignore that other transversal just for a minute, what we have is a 74 here, and then we're going to get a 74 down here. Okay? What's that going to lead us to? So we got a 45. We've got a 74 now, right? Because the 45 is right here, the 74 is there. We can figure out that angle. Okay? Okay, so where we're at is we'll add 74 and 45. That's going to get us 119, and then 180 minus 119 gets us 61 right here. Now, that means we've got a 61 there, okay? And if you isolate just this portion right here with these two, all right, what you basically have is angle 1 and a 61-degree angle, and those are vertical angles, these two right here. So we're using, a couple different concepts here. Corresponding angles and then vertical angles, and angles add up to 180. So the measure of angle 1 is 61 degrees. Okay. All right, prove that this triangle is isosceles. So I'm going to, step out for a second. I'll graph it and put some things on it to not waste any time. Okay, so back at it. What I did was I drew the triangle And I kind of got all the sides broken down here. So what we've got is AC is right here, okay? And we're gonna figure out, we're gonna try that to solve that it's isosceles. Doesn't look like it to me, but I'm gonna try and figure out for sure if it is or not. Um, so what it is we're gonna see down 7 over 6. So we kind of made this right triangle so that we could get the length of it. So what we're going to do is for the distance, because we can't do anything right now with angles on coordinate geometry. Once we learn trig, we will be able to, but the intent of this problem is to calculate the distance of our two sides, or the length. Distance or length, whatever you want to call it. Okay? So we're going to start with AC, and it's 7 squared plus 6 squared. I use D for distance. You know, some people just say C squared, whatever. So that's 49 and 36. Okay. And just let your calculator do that. That's fine. So we've got 75 there. Oh, wait a minute. No, 85. Sorry. 85 equals D squared. And then we're going to square root both sides. Now, what happens is that's not a perfect square, so you're going to get a decimal. It's a little over 9, probably 9.2-ish. So then we're going to go in, but leave it because, so now we got the distance of, or the length of AC. Square root of 85, just leave it as a square root. Okay, AT, what we're going to have is 8 squared plus 5 squared equals D squared. And, okay, yeah, like I thought. This is going to be 89. Did something go wrong here? 49 and 36. Yeah, I'm right. It is 85. Okay. So, these are not the same. It says prove that it's isosceles. Okay, did I do something wrong here? It is not isosceles, because there's no way CT. There's no way. I'll go ahead and calculate CT. Okay, we got 2 and 2. There's no way that's going to work. But at least I've calculated it now so that I can actually speak to it. You know, you don't want to say something that you didn't actually prove. Okay, so CT's length is square root of 8. AT's length is square root of 89. Triangle CAT is not isosceles. And that is because all the side lengths are different. So no two sides are the same. All right. A strange problem. So it said to prove that it's isosceles, and it's not. All right. Let's try this one. Hopefully this one's going to be a right triangle. Again, I'll go ahead and graph it, and then I'll come back after it's graphed. Okay, so number 9's graph now. This is really not a realistic problem that we'd give you. So I'll explain what's going to go on here in a similar question, potentially on the test. In a right triangle, what we need to show is that two sides have slopes that are negative reciprocals. Now that's what's usually going to happen on a coordinate geometry problem where you're trying to show it's a right triangle. So I don't know. I don't know why they're doing it with sides that are clearly perpendicular. I am going to go through the process. We know TC is going to be the hypotenuse. We know this is going to be a right angle, but we have to go through the process. So what we're going to say is we're going to tell whoever's grading that we're going to calculate the slopes. So AT has a slope, and use M for slope. We've got 6 there and 8 there. Okay. So it's going to be a rise of 6, a run of 0. Okay, so slope is 0. That doesn't mean it doesn't have a slope. It means the slope is, whoops, I'm wrong there. Terrible. Okay, ignore that. It's not a zero slope. Really bad. That's a slope that's undefined. Okay, let's not mix up the two. That has no slope or an undefined slope. Okay, what we have for AC is that our slope is 0 over 8. Now that's our zero slope. 0 divided by 8 is 0. 6 over 0 is undefined. This is one of those special cases where we're not going to get negative reciprocals. What we're going to get, in fact, is just this special case. Okay, so AT is perpendicular to AC. All right, my evidence is it's the special case where slopes that are undefined and 0 respectively um, are perpendicular segments. Okay, so that's what we're going to say there. Usually we need negative reciprocals. We're not exactly going to get that. It's kind of a special case. So since AT is perpendicular to AC, we've got angle A is a right angle because perpendicular segments form right angles. And then, so the triangle CAT is a right triangle because it has a right angle. Okay, so that's that one. Again, never going to happen on a test. We're going to switch that so that, you're going to have a slope of, I'm just going to make this up real fast for us. You're going to have something like that's got a slope of 1/2, okay, usually. And then, of course, what we're going to do for perpendicular is we're going to throw in something that's got a slope of -2 over 1, okay? So that's going to be more realistic for a problem, okay? So just be prepared for that. We'll move on. Let's see. Oh, that'll be good for this video, and what we'll do is we'll pick it up for the next one.